Probability and statistics is the branches of mathematics concerned with the laws governing random events. It is used to understand chance, to collect, analyze, interpret, and display. Probability and statistics is essential in the modern world, which needed in electronic media.
Binomial distribution. The criteria of binomial distribution are: first, have two possible outcomes; second, have n repeated trials; third, have same probability success in every trial; fourth, the trials are independent, means does not affect the result on other trials. This is the formula for binomial distribution, where x is the number of success, n number of trials, p is the probability of trial success, and q is probability of trials failure. Normal distribution are also known as bell curve. The criteria of normal distribution are: first, all symmetric; second, mean, mode, median are all equal; third, 50% are left of the mean and another 50% are right of the mean; fourth, total area under curve is equal to 1. This formula is used to transform to standard normal distribution, where x is the value of measurement to be standardized, mu is mean, sigma is standard deviation.
Next, I will explain about the Poisson distribution. It was named after French mathematician Simeon Denis Poisson. It is a discrete function. Then, it can be used to estimate that something will happen in x in number of times. Then, the probability distribution is a result from a Poisson experiment. So, what is a Poisson experiment? A Poisson experiment is a statistical experiment that has the following properties. Number 1, the experiment results in outcomes that can be classified into two, either its successes or failures. Number 2, the average number of successes that occurs in a specified phase is known. For next slide, Poisson probability sum stated in the slide will use the statistical table and proof, while the Poisson distribution formula is popular for modeling the number of times an event occurs in an interval of time or space.
So we choose normal distribution to calculate the light bulb's lifetime, so it shows the applications of it in our daily life. The question state is the lifetime of a light bulb in a certain application is normally distributed with mean equals to 1400 hours and standard deviation equals to 200 hours. So remember, for normal distribution, we use Z transform. A. What is the probability that light bulb will last more than 1800 hours? So it didn't include the 1800. So first we use the Z transform, 1800 minus with the mu, which is the mean, and standard deviation, so we get 2. And since it want more than, so the graph is to the right of the 1800. So 1 minus 0.9772, this is from table A.3. So we can look here, this is the Z. So the area under the graph is 0.0228. So this is it. And B, for B question, a particular light bulb lasts 1580 hours. What percentile is its lifetime on? So for this question, x equals to 1580. So we can straightly take the Z, which is 0.9. So from table A.3, we know that 0.90 is 0.8159. So the percentile is 81 percentile approximately. So from the graph, we can know the area is in this area.